So, welcome to the fourth episode of the Spatial Podcast. Today, we are going to talk with the project use case leaders. Spatial focuses on state-of-the-art concerns and practices, and then targets practical use cases concerning AI in ICT systems and cybersecurity. Those are chosen to connect and promote business cases that are beneficial for the EU industry, including SMEs. We remind the audience that Spatial is a European-funded project that tries to achieve trustworthy artificial intelligence as a top priority for Europe. Today, we have David Solans from Telefónica. He will talk about the use case of privacy-preserving AI on the edge and beyond. Secondly, Edgardo Montes de Oca from Montimage will answer the questions for the use case, improving explainability, resilience and performance of cybersecurity analysis of 5G, 4G, IoT networks. We also welcome Michell Boerger from Fraunhofer Fokus that will talk about accountable AI in the emergency eCall system use case. And last but not least, we welcome Michal Simcik from WithSecure. He will talk about resilient cybersecurity analytics. So welcome all of you. Welcome, David.
Hello.
And Edgardo.
Hello.
Michelle.
Hello.
And Michal.
Yeah, hi.
So we are going to start by getting to know better the goals of the use case with Telefónica. David, so what specific objectives does the Spatial project aim to achieve when designing and implementing privacy-preserving AI applications?
Good. So in Spatial, we brought a demonstrative use case which is based on federated learning. Then, federated learning, what it is an AI training framework that has the benefit of not requiring sending personal data to a server where the AI model will be trained. Instead, it trains AI models locally on the personal devices and then sends the models to a central server that aggregates them, right? By default, the fact of not requiring sharing potential sensitive data adds an initial layer of privacy preservation. However, this is not enough, because the state-of-the-art has already shown how private information can be retrieved directly from an AI model, even when it has been trained using federated learning. To that extent, within Spatial, we have developed an additional level of privacy preservation that uses differential privacy, what is basically the gold standard in privacy because it offers mathematical guarantees of privacy preservation.
Oh, thank you very much. And how crucial is ensuring privacy in AI applications, especially within the telco environments? And how does the proposed framework address this concern?
So, machine learning models that are trained without privacy-preserving algorithms have the risk of memorizing sensitive information about the training data. Publishing the models or exposing the outputs can, of course, consequently risk the privacy of the clients whose data has been used for training. So this is a risk, right? And considering this risk and also the scale at which our systems and networks operate in the telco environment, it makes clear that there is a need for ensuring privacy preservation to reduce the risks and ensure the safety of our customers.
Okay. And can you elaborate on the importance of tailoring AI privacy solutions specifically for telecommunications, and what benefits do you anticipate from this approach?
Sure. So telco companies are starting to view their networks not only as a well-connected communications channels, but also as a collection of computing nodes that form together a very large supercomputer. So basically this supercomputer should be able to train vast AI models using the decentralized topology of the inherent networks, right? In this setting, federated learning seems to be a very promising paradigm. However, before being able to make a practical and effective use of the supercomputing capacities that are offered by these networks, we need to be sure that we can effectively address significant issues as the protection of the user's privacy, which is one of the main concerns, but not the only one.
Okay, thank you very much, David. And Edgardo, I would like to know what specific objectives does the spatial project aim to achieve in generating AI ML techniques that are more transparent, resilient to adversarial attack, precise and efficient?
Well, AI has the potential of recognizing abnormal patterns from a large set of time-varying and multi-dimensional data and delivering fast and accurate decisions. However, the adoption of AI methods in IoT and 5G networks is still in infancy. In spatial projects, what we aimed is to enhance the performance, explainability, and robustness of our AI-based security applications for network traffic analysis and anomaly detection in these type of networks, and address some of the challenges we have, which include, for instance, the lack of real-world data, because network operators cannot share their data, so we need to produce this data to be able to test and develop our AI applications. And there's also the lack of explainability. AI models applied in security solutions focus mainly on accuracy and performance and do not readily offer an explanation of why a particular decision has been obtained. So explainability of the decisions has become critical in these type of networks and this type of applications. The lack of resiliency against adversarial attacks is another issue. AI models are vulnerable to adversarial attacks, where adversarial inputs of small, carefully crafted perturbations and real test data can fool the underlying ML models, machine learning models, into taking the wrong decisions.
Okay, and how do these goals address the challenges faced in AI ML applications, particularly regarding cybersecurity risks and the protection of 5G and the IoT networks?
Well, we aim to enhance the performance, explainability, and robustness of our AI-based security applications for network traffic analysis and anomaly detection in 5G and IoT networks. So for this, we address the challenge that I just mentioned by deploying our own real 4G, 5G EOT testbeds to be able to generate the traffic that we need for the development of the solutions, and also develop the explainable AI framework, which we call XAI, explainable AI, for resilient 5G EOT traffic analysis. So we design and develop an open source framework consisting of two main components, which is the network traffic analysis and the explainable techniques for resiliency that are integrated into the spatial platform. While the network traffic analysis component aims to fulfill the need for effective analysis and classification of encrypted traffic using advanced AI techniques, the explainable AI for resiliency component aims to enhance the robustness of the AI models built within the network traffic analysis model, making them more resilient against different types of adversarial machine learning attacks.
Okay, thank you very much, Edgardo. Regarding the Fraunhofer Fokus use case, Michelle, what specific objectives does the spatial project aim to achieve in designing and implementing an explainable and accountable eCall functionality based on AI/ML algorithms within a next generation IP-based telecom platform?
Yes, thank you for your question, Blanca. So in our spatial use case, we want to integrate an accountable AI-based emergency detection into a next generation emergency communication system. This means that by using AI technologies on the patient side, we aim to automatically detect emergencies and then automatically establish an emergency call to a trained medical professional that can immediately initiate help. In this way, we hope to improve and accelerate the entire emergency chain. In our developed use case system, AI is used to recognize emergencies based on supplied IoT sensor data. And in the context of the spatial project, we are currently studying the detection of heart attacks based on ECG sensor data. Such ECG data can be collected via wearables such as smartwatches, which are widely used today.
Okay, I see. And how does integrating rich media emergency calls encompassing voice, text, IoT sensors, and video enhance the effectiveness and responsiveness of the eCall system?
So the potential of next generation IP-based emergency communication systems compared to traditional phone-based communication systems is very manifold and promising. So for example, in our use case, the IP-based emergency communication system allows to transmit sensor data, the decisions of the employed AI models, as well as explanations why this specific situation was classified as emergency during the emergency call. In this way, the medical expert who receives the emergency call can get a precise overview of the current situation and better prepare or initiate the necessary medical countermeasures.
And can you elaborate on how artificial intelligence and machine learning algorithms will be used to automatically trigger NG 112 calls in emergency situations? And also, what benefits this approach offers over traditional methods?
Yeah, sure. As already mentioned, AI models are used in our systems to automatically analyze IoT sensor data collected at the patient site. This can include data about the patient's cardiovascular condition, such as ECGs or heart frequency data, but also acceleration data from smartphones can be used to recognize, for example, faults that are specifically relevant for older patients. So, if the AI models recognize anomalies in the available data, the patient is directly informed and an emergency call is automatically triggered within a 10-second time window. Of course, traditional systems do not offer those options, and so it can happen that, especially for patients living alone, no one notices the serious emergencies, such as the heart attack or the fall, and therefore medical help is provided far too late.
Okay, thank you very much, Michelle. And Michal, what specific objectives does With Secure aim to achieve through its research on evasion and poisoning attacks against machine learning models in cybersecurity?
Yeah, first of all, thanks for having me. So, the, when it comes to specific goal objectives, we want to increase the security of overall the security of the IT systems by developing the tools that specifically target ML models that some of our clients or people in general are now embedding into their systems. We want to also increase the awareness of users that models can be attacked and they can be vulnerable, and it's good to test them before they're integrated fully into the production systems. But we'd also like to continue the research efforts on adversarial methods and continue to develop practical tools that allow for fast and effective testing of the model's resilience.
Okay, thank you so much. And can you provide insights into how It Secure's research aligns with broader objectives or goals within the cybersecurity field?
When it comes to the entire field, we are much more focused on protecting our client systems by making sure that models that they work on are safe and trustworthy. That means that we want to increase their own trust into the models that they're developing and putting to their products. We want also, when it comes to cybersecurity perspective, we want to decrease the attack surface that the threat actors may use to attack our client system.
Okay, thank you very much. And now I would like to know a little bit about the challenges. So, for example, David, what are the primary challenges associated with the performance of privacy-preserving machine learning AI methods, particularly when deployed on edge computing nodes within telco environments?
Oh, thanks for your question. That's an interesting one. So, while deploying AI on the edge computing nodes, telco companies like us confront challenges of many types, right? In one hand, in order to guarantee the user's privacy, as we have been discussing, we typically need to add some type of noise to the data or the learning function. This typically has an affection on the system utility or accuracy that we can obtain, right? On the other hand, there are restrictions on the computing capacities that the edge computing nodes have. These restricted computing capacities add significant constraints for the incorporation of highly complex AI models that include privacy preservation techniques.
Well, thank you very much. And could you provide examples on how classical and deep learning methods encounter difficulties maintaining privacy when deployed in telco environments, and also how spatial intends to address these issues?
Sure. So I'll give examples beyond telco environments. So more in general, machine and deep learning models have shown to be very fragile against different types of privacy attacks. Examples of effective privacy attacks are the so-called membership inference, reconstruction attacks, or property inference attacks. Personally, I find the case of the reconstruction attack particularly interesting, as it has been demonstrated to be able to partially reconstruct samples that are present in the training datasets. This, in the worst case, could imply that an skilled attacker could retrieve personal and sensitive information from the customers for whom their data was included in the training dataset.
Okay, thank you so much. And Edgardo, for example, what are the primary cybersecurity risks associated with AI ML techniques? And how does the spatial plan to mitigate these risks, especially in the context of 5G and IoT networks?
Well, yeah, as was mentioned a little bit previously, the main challenges and the main problems that we are trying to address in the spatial project are how to deal with how to detect and deal with adversarial attacks, how to deal with data privacy and security, and how to detect the bias of models and also make the models more explainable. And then the dependency we have on the data quality, because machine learning algorithms require quality data to be able to train the models, and so that they become accurate in detecting the anomalies that we want to detect. So to mitigate these risks, the spatial plan is working on several strategies. First of all, there's a robust model validation, where spatial employs rigorous validation techniques to assess the resiliency of AI ML models against adversarial attacks. So this includes stress testing models with adversarial inputs and implementing defensive mechanisms to detect and mitigate attacks in real time. And then there's secure data handling that spatial implements by implementing robust encryption and access control mechanisms to safeguard sensitive data sets. One of the techniques that can be used is using federated learning, where the algorithms are distributed so that the data is not shared in a central way. And then there's data quality assurance, where spatial implements measures to ensure the quality integrity of the training data, including data cleaning, validation, and augmentation techniques. This helps minimize the risk of relying on inaccurate or biased data for model training.
Okay, thank you so much. And Michelle, what are the primary challenges associated with developing effective and accountable algorithms for analyzing diverse data sources and triggering NG112 calls automatically during the emergencies?
So a critical challenge in this context is that the deployed machine learning models can reliably detect emergencies and distinguish between critical and non-critical situations. So for example, if the AI system generates too many false alarms, the emergency call center may be congested and employees will no longer be available for real emergencies. In contrast, if the AI models do not classify real emergencies as such, human lives may be put at risk because appropriate medical assistance is not initiated in such cases. Therefore, the performance of the AI model and the definition of an optimal trade-off between false alarms and missed emergencies is of crucial importance for our use case. So, although the integration and deployment of a next-generation ecosystem poses complex challenges, we believe it's worth the effort as the new opportunities it provides are essential for improving the whole emergency chain. So, for example, with the help of next-generation ecosystems, the GPS location of the patient can be reliably determined, allowing assistance to be sent precisely to this location. And furthermore, the video functionality allows first responders at the patient site to be specifically instructed by the medical expert answering the emergency call. So this can include, for example, concrete reanimation measures. So, and finally, the additional data available helps to better assess the current emergency situation and increase the transparency of the whole emergency situation.
Okay, thank you very much. And could you provide further insights into the requirements for ensuring accountability in AI ML algorithms used for these eCall functionalities, especially concerning transparency and traceability in decision-making processes?
Yeah, sure. Although we have only talked about the performance of our employed emergency detection model so far, this is not the only relevant aspect of our system. So we also want to ensure the accountability of our system, which means that we want to be able to understand the AI decision making and explain why the AI models have detected an emergency. So to this end, we use so-called explainable AI methods, which attempt to explain the complex and opaque decision making of the employed black box AI models. So in this context, it is particularly important that the AI explanations created can also be understood and interpreted by the users of our AI systems, as these explanations are designed to help them to understand the system's decisions better.
Okay, thank you very much. And Michal, what are the primary challenges with secure faces in studying aviation and poisoning attacks against ML models used in cybersecurity?
So the main challenges were came from the research space that was done in this domain, and there were a couple of things that we had to change or address in able to be able to apply those methods effectively. So previous methods were usually specific to some ML models or some ML frameworks. The methods that were previously developed only work on specific data modalities, so they would work on text or images or tabular data. And to render attack successfully, you had to find the right parameters that would make the attack successful. So there were no hyper-optimization of those parameters. The success criterion of the attacks were also not could be modified. It was not always was optimal for our cases. We couldn't find any clear and transparent methods for reporting the results and some overall metrics about how the attacks really work on the models. And there were no clear indicators what should be done to actually increase the model's resilience.
Okay. And how does WithSecure plan to address challenges such as privacy concerns, data handling costs, and security risks inherent in its research endeavors?
I mean, the challenges are we try to tackle them by developing like most effective tools that we can. So the tool that we developed for the special project can be used for various models and various data types. So here you can address the data handling costs. We also introduced the capability to run the hyperparameter optimizations, which also decrease the cost and make the methods more effective. We add a lot of flares, like adding custom success criterion for the attacks, which is very important in the cybersecurity space, actually. We added our own metrics to detect the complexity and detectability of the attack. And we also give hints after the attacks are run to inform the users how effective was the attack and what changes they can do to increase the security of the infrastructure.
Okay, that sounds really interesting. So we are going to talk now a little bit about the impact, which I think is very important. So we will start with David again from Telefónica. What potential benefits do you foresee from enhancing the performance of privacy-preserving machine learning AI methods in telco environments, both for service providers and end users?
Thanks, Blanca, for the question. So, using a broader perspective, at the end, we all aim at creating technology that makes a better world, right? So, for that, the idea of responsible and trustworthy AI, which is the umbrella where privacy falls in, aims at ensuring security and safety of people while developing and using these AI systems. This is done by reducing the negative risks of those systems, such as reducing the privacy-related risks. That is done by adding further layers of privacy preservation in order to guarantee that the data is not leaked in an intended manner.
Okay, thank you very much, David. And Edgardo, what are the expected improvements in explainability, resiliency, and distribution of AI ML techniques as a result of spatial initiatives? What do you
Well,
think?
we bring improvements in the explainability by providing transparency into the AI ML based network traffic analysis models to improve the decision making process and enabling stakeholders to understand the factors influencing the model's prediction. We also provide detailed insights into the contributions of individual features or factors to model predictions, enabling stakeholders to identify the most influential factors that assess model reliability. Regarding resiliency, we enhance the robustness of AI models built within the network traffic analysis model, and we make them more resilient against different types of adversarial machine learning attacks by incorporating advanced training as well as evaluating the impact of different adversarial attacks to our models.
Okay, thank you very much. And Michelle from Fraunhofer Fokus, what are the expected outcomes regarding coordination and communication among citizens, call centers, and first responders in emergency situations as a result of implementing the explainable and accountable eCall functionality?
So we hope that the additional functionality provided by our system will improve the emergency chain already on the patient side. So as the emergency call taker with medical background has access to relevant information and has also a video call has been set up, he or she can calm the patients in serious situations or relieve their fears. But we also hope that this functionality will enable to involve and instruct available first responders that are close to the patient's location, for example, housemates. For example, the medical expert can then explain to them via the video-based eCall how to apply first aid measures or position the patient into the recovery position.
Okay, that's really necessary. And how might improved responsiveness and accuracy of the eCall system enhance emergency response efforts and potentially save lives?
Yeah, so we believe that our AI-based emergency communication system can improve the efficiency of the emergency chain and emergency response processes. So, for example, we hope that the additional data and explanations of the AI system's decision making can help call center agents to better identify false alarms. Furthermore, we also expect that this will help to differentiate better between urgent and non-urgent emergencies, and therefore allows the call center agent to distribute available emergency doctors more efficiently. And as a result, we believe that everyone involved in the emergency chain will benefit from our systems. But In addition, we also hope that once the system has been accepted and widely used, it will be expanded and integrated into additional clinical processes. For example, if also the involved hospitals have immediate access to the relevant data, they can deploy required doctors more quickly and efficiently at the hospital site. And in addition, waiting times could be highly reduced, and for example, emergency rooms could be prepared more quickly. Therefore, we hope that our current AI-based prototype is only the first step towards improving the emergency chain with the help of AI, and that further interesting use cases will arise from the prototype in the coming years.
Thank you very much, Michelle. And Michal from WithSecure, what is the anticipated impact of WithSecure's research on detecting and mitigating advanced cyber threats in the cybersecurity landscape?
So the impact that we want to bring is we want to push the forward research, and we want to keep working on the methods for attacking ML models. We would like to building tools that brings the theoretical knowledge and put the knowledge into practice. Tools that allow for fast and versatile testing of ML models, thus increasing the security of any given IT system that actually has those systems built to their infrastructure. And we want to give tools to people that would help them to anticipate and mitigate some security risks that they may have in the model's development cycle and be able to assess what's the security of different models as they go through continuous iterations and try to find the best model. And then it can compare whether the models that they're creating actually, whether they increase the security or introduce some new challenges when it comes to the possible ways of attacking them.
And can you elaborate on how WithSecure envisions its research contributing to the enhancement of cybersecurity practices and defenses against evolving cyber threats?
Well, we would love to continue to increase the awareness that ML models are susceptible to attacks and can be easily manipulated. Edgardo gave a good example that the input features that or the data that comes into the model can be manipulated in such a way that the model actually is making wrong decisions. And it's really something that we should be aware of. We would like to continue to building the practical tools that allow for overall security assessment and give people a much nicer tool to basically figure out what the security risks are involved in the process of creating ML models. And there's also this AI hype that I think we all observe, and AI is put into various products, and it's done sometimes without actually thinking about the security and what sort of drawbacks it actually has. And this is something that we would also like to work on and increase the awareness of the drawback that potential security risks may bring to the infrastructure that is built globally.
Okay, so thank you so much. I think this episode came to an end, so I have to thank you, the four of you, David, Edgardo, Michelle, and Michal. Thank you, the audience, also for tuning in to this episode of Spatial, in which we explored the project use cases. We dove deep into privacy-preserving AI on the edge and beyond with Telefónica, discovering how advancements in this area are shaping the future of privacy-preserving AI deployment. We also explored the efforts of Montimage to enhance the explainability, resilience, and performance of cybersecurity analysis across 5G, 4G, and IoT networks, highlighting the critical importance of transparency in cybersecurity. Our journey today continues with Fraunhofer Fokus work on implementing accountable AI in emergency eCall systems, which showcased how AI can be leveraged responsibly to improve emergency response services. Finally, we discussed WithSecure's contributions to resilient cybersecurity analytics uncovering innovative approaches to combat evolving cyber threats. So thank you so much. Stay connected with us as we continue to explore the ever-evolving landscape of technology and its impact on society. Thank you so much.
Thank you, Blanca, for hosting this podcast.
Thank you very much.
Thank you, Blanca.
Thanks very much.